Hello everyone. Today I am going to present a beautiful presentation about the applications of quantum mechanics in daily life. So most specifically the lasers. So in this slide I am going to give a short history about the laser. So in 1917 Einstein gave a concept of stimulated emission, and then after the first laser was invented at Hughes Research Laboratory by Theodore H. Wayman in 1960, and basically it was Charles Hart Downs and Arthur Leonard Shallow principle. When we read between the lines, lasers stand for light amplification by stimulated emission of radiation. Actually, it is the property of the laser that it is actually the coherent light. Okay, what do you mean by coherent? Those light having the same phase difference and the direction are called coherent light. And what do you mean by coherence? It is the property of those lights which has the stationary wave, and those stationary wave interfere with each other. Okay, this graph shows the comparison between the frequencies of the ordinary light and the red laser. Okay, now here we have the frequency for the red laser is 700 nanometer, and this is visible through our naked eyes. Now this slide is actually about the stimulated absorption. It is the first step which is happening inside the laser working. um, what do you mean by stimulated absorption? Well, inside the lasers we have the cavity, and inside the cavity we have a medium, most probably gaseous medium, maybe the helium or neon. And we know that there are billions of atoms having electrons. When those electron, most specifically the ground state electron, absorbs a sufficient amount of energy in the form of light, and we know that in those light that light we have small photons. Their photons are absorbed by the electrons and jumps to the excited state energy. I have mentioned one small line type of this picture to differentiate between the ground state energy and the excited state energy. And when the electron absorbs sufficient amount of energy, then it will automatically jumps to the outer shell or excited shell um, state. Okay, this is what the first step is happening inside the laser, which is stimulated absorption. Well, this slide is about the spontaneous emission, which is actually the second step of the laser working. So as we all know that the electron in an excited state will not remain for a long period. So it will emit that energy which it has absorbed here and go back to its ground state. Now additionally, what's happening, the new coming photon will knock out the previous photon absorbed by that electron, and that new coming photon and the previous photon are identical to each other, and the electron go back to its ground state. Now which means the new photon and the coming photon and the previous photon are coherent with each other. Now, the stimulated emission is the third step of the laser process. As we know that inside the cavity we have two mirrors. One is total reflected mirror, and another is partially reflected mirror. And inside those mirrors we have those medium, which is a gaseous form. So we increase the process of spontaneous emission, and this process is what the amplification process done by this partially reflected mirror and total reflected mirror. Well, after the electrons which are in metastable state come back to a normality state by releasing the energy in the form of packets which are coherent with each other, and these coherent wave packets will emerge from a small hole of the reflected mirror, and this is the laser which is coherent. And now, what is metastable state? This metastable state is actually the electron in that state having energy lower than the excited state, but much higher than the ground state energy. Now, this slide is for better understanding of stimulated emission. Here we have two pictures. In the left picture, we have an atom having an electron orbiting around it. We have the orbits having the different energy for a ground state and the metastable state and the excited state. If an electron emit the energy from a metastable state, it will go back to the um, ground state. On the right picture, suppose that if an atom is in the ground state, now if it absorb for energy for time being, it will go to the excited state, and for a metastable state it will absorb 3.9 and vice versa. Now this slide is to formulating the absorbed energy done by an electron of an atom. Simply what we can do, the change of energy or the energy absorbed by an electron of an atom equals to the energy E2 minus E1. D2 is for excited level and E1 is for ground level. As we know that the energy absorbed by an electron in the form of photons, and we have change of energy equals to h nu. H is the Planck's constant, and nu is for the frequency of that photon. In this slide, I have mentioned the energy graph for the fluorescence and phosphorescence. The excitation and de-excitation process also happening in this kind of materials. These are those materials which absorbs the daylight or the sunlight and illuminate in the dark rooms. Now, this is a small animation to give a better understanding of the excitation and the excitation of electron and the stimulated emission, stimulated absorption and spontaneous emission. Now here we have an electron which is on the ground state. The coming photon having the frequency of nu is absorbed by that electron which is in a ground state. Now after absorbing this photon, it will get excited and go to the excited state. Now here electron is jumping to the excited state from the ground state. Now out of that we have spontaneous emission. Now, as you already know that the electron is in an excited state, having sufficient amount of energy. After releasing that energy in the form of photon, it will go back to the ground state energy. Now, these photons are coherent in phase, and what the releasing energy of the electron on their own is known as spontaneous emission. Now, how we can calculate the energy of an electron in a different position, either is in a ground state or in an excited state? We have Einstein-Planck relation equation of energy E equals to hf or h nu, where f or nu is also the frequency, representing the frequency, h for the Planck's constant, and E for energy. We have a general formula En equals to n square pi square h cut square 2 ml square. N is representing the electron, the position of the electron, either it is in a ground state or in a excited state. If it is in a ground state, we put n equals to 1, and h cut is the Planck's constant. After putting those values, we get the energy of an electron in a ground state, and so on. Here I have compared the energy of electron in a ground state and the energy of an electron in the second shell, or it may be the excited electron. So E2 energy is 4 times greater than the E1. Now this slide is for the population inversion. As we all know that we have billions of atoms of medium inside the cavity. Some of atoms may be excited and some of atoms may be not excited. So the photons, due to the amplification, will not affect those electrons of an atom which are already in excited state, and it will pump or excite those electrons which are in a ground state energy. Here we have the proper image of the cavity, where we have atoms and the frequency or the frequency nodes producing in the different states, N1, N2, N3, and N4. Uh, the L is the length distance between these two mirror, the refracted mirror and the partially mirror. Now, if you want that, what is the frequency of the coming light or the laser? Here we have a formula F equals to N V over 2L. And if we put V equals to the speed of light and L by measuring the distance between the two mirrors, we get the frequency of the N1, the N2, N3, N4 by putting that these values. Now here is the graph for the frequency of different color laser. We have the frequency for red laser is 400.05 terahertz, and secondly, the energy of the blue laser light is greater than the red laser light. For better understanding of population inversion, we have a 3D animation which gives you a better idea that how the laser works inside the cavity. Now here an ordinary atom which is in a ground state will go to the excited state after absorbing the energy. The upcoming photon is now knock out the photon which is already absorbed by the excited atom. And as we all know that we have a billions of atom, and this process is the stimulated emission process actually is happening so many times, or we increase the stimulated emission by the partial reflected and the total reflected mirror. Hence we get the coherent waves, and at last it will emerge out from a small hole of the reflected mirror. Now this light is for formulating the frequency of different colors lasers. I mentioned the red laser frequency, which is around 400.05 terahertz. And if we want that how many nodes are there inside the laser, red laser, by putting the value of f, we get 2667 nodes inside the red laser light. Now this slide is for the allowed frequency for the red laser pointer, and we have 2600 frequency allowed in a visible range. Okay, now it's really important to mention the uses of laser in our daily life. First of all, in the medical field, we use laser for our eye treatment and also for the liver treatment. Due to its high frequency and the focus characteristic of laser, we can treat our eyes, which is really impossible by the conventional method. And also due to its high frequency and high penetrating power, we use for welding and cutting, and also we use this for surveying to measure the long distance between the huge gigantic objects. And laser in the communication, we know that the fiber optics cable, which are for long distance communication, especially for our internet usage, we use lasers due to its in and out signals at the same time. It's giving us more, the beautiful connections for a long distance. And for heat treatment, we use laser for heat treatment. The automobile industry, the camshaft are hardening. The automobile camshaft is done by the use of carbon dioxide lasers without any damaging or affecting, and it's really impossible to treat or to reuse the camshaft by the conventional method. And the barcode scanners, we saw many barcode scanners in the huge, in the big malls, and in the pharmacies. So in today's world, lasers are used in a biometric verification, which is used to identification of the product and etc. And for that, for the bar scanners, the helium neon laser are used for that purpose.